Welcome, Arcadia students and everybody else watching. My name is Kevin Lothridge. I'm the Executive Director at the National Forensic Science Technology Center at Florida International University. I'm very pleased to be able to speak to you today in this seminar. Sorry I couldn't join you physically, but the next best thing is us being able to live cast this to you guys. I have a Bachelor's of Science degree in Forensic Science from Eastern Kentucky University. I have a Master's of Science in Management from National Louis University, and I'm currently working on my PhD in Forensic Chemistry from Western Sydney University. So I have to tell you, being a forensic scientist was something that was more than a job. It is truly a career. I actually worked at the Pinellas County Forensic Laboratory doing controlled substances analysis as well as fire debris analysis. And one of the deals I made with myself when I got out of school back in the 80s was that if it became too boring, I'd find something else to do. And fortunately, 34 years later, I'm still here working in forensic science. I think the real important thing to remember is that we use science every day to solve complex matters, just like you guys are learning in your school sections. But it can also be interesting because one of the things as a forensic scientist you have to do is be able to take complex things and make them simple. I know that that's part of the training you guys have gotten. They've told you, take the work you're doing, explain it to friends and family. Well, it's really important that we do this as just a second nature thing that we do in our day-to-day life. Science is very, very important. If you look at the National Forensic Science Technology Center logo, S is really something that we point towards. You really try to make the career fun and interesting, and I hope that you, once you graduate with your degree, find it as interesting as I do. If you have any questions, you can actually put those on the chat box in YouTube, or you can tweet to us at NFSTC. So let me tell you a little bit about the National Forensic Science Technology Center at Florida International University. We're very different than operational labs. If you think about how we got started here at the NFSTC 23 years ago, probably longer than many of the people in the room have been alive, we actually were driven out of the O.J. Simpson trial. It was the first time that mainstream forensic science was going to be on TV in a live setting, not a docudrama that we see. And the American Society of Crime Lab Directors realized that volunteers probably could not continue to do the work that we needed to do to move forensic science forward. So they gave us $1,500 and a mission to do good things. And for those of you that have studied a little business, in 1995 it cost $1,475 to incorporate a nonprofit in the state of Florida. We took the other $25 and bought some adult beverages to figure out what we were going to do because they said don't come back for any more money. If you look at where we're at now, starting with one full-time person in 1996, we now have 68 people dedicated to doing forensic and biometric support work all across the United States as well as internationally. In January of this year, knowing that it's good to combine forces, we joined Florida International University. Florida International University is the fourth largest university in the United States, the largest historically Hispanic university in the United States, and it's in the top 100 universities according to U.S. News and World Report. Last year, in 2017, FIU researchers got about $116 million in research grants, and we're always continuing to try to grow that. As part of joining Florida International University, we were asked to organize with other centers at the university a preeminent program. And our preeminent program was selected and awarded in May of 2018. The name is the Global Forensic and Justice Center. What that did is it combined the best of all the things you would see in forensic science and justice. So not only does it have the conventional teaching and research portion, but it now has the justice and fair administration of justice as well as the National Forensic Science Technology Center. This allows us to work in different areas to seek more funding and more different types of grants. As our part of the preeminent center, the NFSTC at FIU really has concentrated the last several years on training. To differentiate that from education, we actually do operational hands-on training for people who are in the military, law enforcement, state and local crime labs, and the international, both law enforcement and military community. This means we actually take the knowledge base that you would get from an education program, apply operational scenarios and do a 70-30 hands-on to lecture type training here at the NFSTC, as well as anywhere that we can take the training. We also have done a lot of work for awareness training for the public, officers of the Corps, and the industry areas. Several years ago, when we started doing military training, there was not much awareness of what forensic intelligence could provide for them, and now they're a large user of forensic intelligence tools. Dating back to 1995, we always knew the importance of quality. If you think about the O.J. Simpson trial, if you studied it any, it was the first time they were asking people, was your lab accredited? Did you really follow your procedures? And you can actually watch video clips of them saying, yes, I sealed everything in a bag while the analyst is on the stand, and then they go to video, which was the first time that ever happened. And you should take a look at that if you haven't seen it, because it's really ask and answer, but make sure you know exactly what you're answering. Not only did we think about quality at the time, which was the American Society of Crime Laboratory Directors Laboratory Accreditation Program, but the NFSTC actually set up the first ISO 25 and ISO 17025 accreditation program in the United States. You may now know it as ANAB, Forensic Quality Services before that, but that actually came out of the work we did here at the National Forensic Science Technology Center. We're also taking that same importance of quality globally now. So we actually do work for the Department of State, and really looking at these developing countries and their forensic science programs and putting that quality into the processes they're using. We do technology evaluations as well, where we get to look at late alpha, early beta technologies, and what does it mean for industry? What minor changes do the researchers need to do to be able to make that an applied tool for forensic science? Later in the presentation, we're going to talk a little bit about some of those technologies, and we'll show you what they are. We certainly wish you were here with us, and I would like to introduce a video about the NFSTC so you can get a picture of what we do here at the NFSTC. Welcome to the National Forensic Science Technology Center here in Largo, Florida. Our facility provides many technology and business services to the forensic community. To truly understand what we do here at the NFSTC, you need to see it for yourself. We always enjoy having clients and colleagues come for a visit. Until you can get here in person, please enjoy the virtual tour.
Largo, Florida is home of NFSTC, where we take forensic science to a whole new level. Our facility houses more than 40 professionals, experts in forensic science, and the business of forensic science. As you look around our front office, you'll see we have several flexible training rooms with complete multimedia capabilities. We create high-quality training by carefully managing every detail. We can create new training or convert existing instructor-led programs to online delivery. Either way, you get a learning experience that's second to none. Here in NFSTC's Studio 3, we have a full media production facility. We can deliver anything from streaming multi-camera live events to mobile broadcasting to high-def production for training and promotional videos. Anything a television studio can do, we can do. We also offer graphic design and website construction to support your project. Technology brings people and ideas together from anywhere, and no one does it better. Come on, let's head back to the lab. This is where our chemistry and DNA scientists work to test all kinds of forensic science tools. Just like what you see on TV? No, it's even better. We train crime scene professionals to use new technologies that will improve their investigations. Here's where we conduct biological screening and DNA analyst training and evaluate cool, new technology to see how well it works. Think the labs are great? They are, but wait till you see our hands-on training scenarios. Here in the NFSTC Training Warehouse, we can set up just about any kind of crime or military scenario to help our students get the skills they need. We build these realistic scenes and can furnish them to any needed specification, so our students get to use their new skills right away. Need a tiki hut? How about an apartment? Or a car as a crime scene? Or maybe your team needs to use field portable forensic gear. Yep, we've got all that and the expertise to help your team get up to speed. What do you do when a crime laboratory is needed in the middle of nowhere? These deployable labs, designed by NFSTC, can fold up and go just about anywhere. Set it up, and in a couple of hours, your team can be moving the investigation forward in a climate-controlled environment. So what can NFSTC do for you? Contact us to see how our expertise can benefit your team. See you in sunny Florida.
Well, I hope you enjoyed the tour video. Sorry you couldn't be here with us, but if you ever get into the Tampa, Largo area and you want to stop by, please just reach out to us and we'd be glad to give you a personal tour. Today, I want to talk about laboratories that are not behind the four walls that we think of. In today's world, a traditional laboratory is not always brick and mortar, because we either need to take them to places where there's been a disaster and that laboratory has been destroyed. We need to take them to a place where a laboratory never existed. So I want to talk about some terms today so we're all on the same page so that we know what's going on and what we're saying. So as we know, the needs are changing globally for forensic service. More of it, different types of disciplines being deployed in the field, and more work being pushed towards the field. So the first term I want to talk about is a mobile laboratory. Many of you have seen these laboratories. They sometimes call them mobile command centers. They are vehicle-based. Sometimes they're actually RV style or bus style, and the services can be provided inside that space. Problem with those kinds of spaces are if the vehicle breaks down, you now have no service. Today we're going to talk a little bit more about a deployable laboratory, which is a customizable, separate facility that can be towed to a location. It can be loaded on an aircraft and flown to a location. It can be put shipboard. So we're really going to talk about deployable laboratories, and we'll show you some pictures and setups of those. I also want to talk about fieldable equipment. This is equipment that is equivalent now to laboratory-based technology, and it's beyond being used just for certain types of analysis. There are some instruments that are not fieldable. So if you took a laser ablation ICP-MS, currently it is not fieldable unless you have the right facility and you take the time to set it up. I'm really talking about things that can be either battery charged, plugged in and used off the battery or off the power that's available, and things that can run in harsh environments. It must be right for the end user community that you're using it for. So there are things that are purpose-built for hazardous materials response teams, crime scene folks, as well as the military. You also need to make sure that the tools that are chosen can be maintained and have good quality assurance by the end user. And we try to work with industry here at the NFSTC to look at those types of projects. One of the most interesting areas of growth that we're seeing in our work that we do both with law enforcement and the military is the application of forensic science to computers and cell phones. Many people call it digital forensics. Sometimes you'll hear it called CellX, which is cellular phone exploitation, or MEDX, which would be media exploitation. Those are typically military terms. In law enforcement, you typically hear digital forensics or computer forensic analysis. Today, our phones are as powerful or more powerful than the computers were when I started in this business so many years ago. This allows for many different types of evidence to be captured that before were not readily available. So everybody probably has a smartphone. Many of you probably have the brand new iPhone that came out last week. If you think about the tools that are built into those phones, we have location, GPS location. We can tell speed and distance through the accelerometer that's in there. We can look at the photos you've taken, which are probably geotagged as well. We can look at sent text messages, deleted text messages, and we can even look at where you hook up to cloud-based services and the information you leave behind there. That is really, really important. There have been many cases in the last year talking about things that are not even just a cell phone. There's things like a Fitbit, or if you think about the new Apple Watch, which has a bunch of tools along with it That is all data that we can use from a forensic intelligence standpoint. Not to mention the fact that the new computers have hard drives between 1 terabyte and greater. You can get portable drives that are up to 4 terabytes. That amount of data has never been processed before. So you have to look at what the training is, how you can get through important data versus just storage items that are on there. While there's many military applications, the law enforcement applications are growing as well. One of the more important things that we've seen in the last several years is the transition from an after-the-fact tool. As a crime occurred, we got evidence, we took our time, and we built a case, and sometime later on it went to court, to more of an intelligence gathering tool. So it's more for the applied crime scene information that can be collected by law enforcement, military folks, and other people, because there's also civil sides of this where we're gathering intelligence at the scene of a crime or an accident. Could be trains. There was train accidents last year where the driver was actually texting and he shouldn't have been while he was driving the train. So it's really important, and the technologies are multi-use. So some things that you may have experienced in your training and education were typical workflows for forensic evidence as it goes from a crime scene, a law enforcement agency, to the laboratory, analysis done in the laboratory, and then actual courtroom testimony is given. What I want to talk about today is the change that we're seeing, which may actually be a change for you folks getting ready to get into the workforce, is field testing applications for law enforcement that were once the purview of a trained forensic scientist in the laboratory. To be successful, to meet all the requirements for court challenges as well as other current scientific challenges, everybody needs to use the proper techniques. That means there needs to be a standard workflow, there needs to be front-end quality on the evidence types, as well as quality through the analysis, the review, and the testing. There needs to be consistent training. One of the things in forensic science that we definitely get questioned a lot on is the amount of training, the amount of science that goes into forensic science. And in your role as a forensic scientist, an academically trained forensic scientist with practical experience, you should lead the efforts in the people that are using these technologies. That means you have to look at the quality assurance and the workflow. You have to provide guidance when systems don't seem to be working right. You have to provide samples to make sure they can check proficiency and ongoing competency, as well as looking at the report, or what we call reach back, which is they can send the data to the laboratory. A trained analyst can look at the data and suggest that they run other experiments or confirm their findings. So again, this field testing application is really, really important, because any agency can buy technology, but they need to make sure they work with their laboratory to make sure the workflow works into what would be required to go to court for an accredited test. And you may be aware of this in the rapid DNA testing, that those systems exist out there where anybody can swab the cheek of an individual or take a single source sample and put it in the device and get a result. But it's still going to need to be reviewed by a scientist at some point in time. The findings may be fine. They may not have to rerun the test, but they're going to have to look at the data that goes through there. So I think we can all agree that many things that were traditionally done in the laboratory under conditions that were set for brick and mortar are moving to the field. Some things that we can talk about. Field chemistry, for example. So with the opioid crisis that's out there, one of the main things we look at is, how do we know what the substances are? Many of these things are white powders. So historically, they would have taken a sample and they may have done a field test kit on it. So people are familiar with the field test kit. This one happens to be a marquee reagent from Nick Kit. It's got one vial in it, so this one's really simple. You break the vial, it goes down upon the color, the material you have in there, and you look for a color change based on the functional groups of the compound. It has false positives and false negatives. So remember, these are just presumptive tests in this case. Now, one of the other interesting things that we have is, if we go to a new field test, there's a device called Detectichem. And it not only does controlled substances, drugs, it also does explosives. But it actually reads the information. It's got a barcode on it. You'd use a barcode scanner. You would scan this device. It's got a camera on it. You can take a picture of the material you're testing. And you basically slide this little card in here. They have the little finger holes. You break the finger holes after you've swabbed the device, and it gives you a colorimetric readout. What this does is it removes some subjectivity of people viewing things. If you've ever done the standard marquee test, I can make it turn purple by putting a non-controlled substance called guaifenesin in there. It's an expectorant. It would be the same exact purple and faster than the opium alkaloids, the heroin that's in here. So while they'll both still react under the same chemistry, if it's one where you think you have to see a color change, maybe not as clear as the guaifenesin example, this would allow you to actually review your test. It captures your test, and it also keeps the data based on that barcode on the back of the device. The other nice thing about the Detectichem device is training on how to use it is actually built into the device. They can watch a video on how to use it. So I'd like to show you a colorimetric video we did some years ago to talk about those subtle color changes.
Chemical evidence is sent to crime laboratories across the country every single day, mostly due to drug cases. With a high volume of samples to work through, laboratory turnaround times and costs continue to increase. As a result, cases may not be prosecuted in a timely manner, and this clogs up the criminal justice system. But properly applied field drug kit testing and system-wide protocols can streamline these aspects of drug investigation. Colorimetric kits are the most commonly used presumptive or screening field test for detecting controlled substances at the scene. They are inexpensive, easy to use, and field portable, allowing investigators to quickly narrow down types of substances and the number of samples requiring lab confirmation. Colorimetric tests are designed for presumptive use only, meaning the substance is thought to be detected but still must be confirmed by laboratory tests. When selecting any field test kit, agencies must ensure the type of kit they select meets important criteria. Kits must test sufficient specificity, meaning the kit is targeted enough to identify particular chemical compounds of interest. This minimizes false positive or false negative interpretations. They also must be adequately sensitive to allow the detection of drugs at concentrations commonly found in street samples. Drugs are often mixed with a variety of adulterants. The test must be able to detect the drug in mixtures. Results must be reproducible. Here's NFSTC forensic chemist Kirk Grates to demonstrate how these tests are conducted.
Today we're going to go ahead and start talking about colorimetric technology, specifically when it comes to looking for particular drugs that are in the field. These type of kits are actually utilized by officers. Suspected substances are actually gathered in the field and they resemble drugs. They can actually utilize these colorimetric test kits to look for cocaine, marijuana, PCP, and other drugs out there. But the particular kit that we're going to utilize to presumptively identify cocaine is going to be the Scott's modified reagent. This kit is a 3-component system. Basically, you just open up the pouch, grab the actual unknown sample, remove the top, take a very small portion of the material, place it into the pouch. Another thing you want to be careful of too, there's a static charge on some of the pouch as well as the drug. As you can see, it's actually starting to move up the straw a little bit. You want to be very careful, making sure that you get all the sample into the pouch itself. Another thing you want to be aware of is don't use too much. You want to definitely keep in within the manufacturer's recommended amount. Also, recap the sample. You want to avoid contamination as well. Make sure you actually tap the sample down into the bottom of the actual test kit itself so it does come in contact with the reagents. Go ahead and close the pouch. Clasp it with the actual clamp and keep tapping just to make sure that our sample does get to the bottom. Now again, you notice I did not overload the test kit. It's very important that we do not do that. It doesn't require very much. All right, starting from left to right, we go ahead and break the first ampule and let the reagent go ahead and exit that ampule. You don't have to continue to crush, and you just shake it for about 5 seconds just to ensure that our sample mixes with our reagent. All right, and we move on to the second reagent. That should turn pink in the presence of cocaine base or cocaine hydrochloride. And again, we're going to wait about 5 seconds or so while we're shaking, just to make sure we get it really good contact with that reagent. And the third step, or the third reagent, we're going to go ahead and break that and shake for, again, 5 seconds. And if there is cocaine hydrochloride or cocaine base present, we should get that characteristic pink over blue. And as you can see here, we got the pink over blue. Now the pink is going to be our aqueous layer, organic layer is going to be our blue. Being that it is pink over blue, we do have probable cause for our unknown sample. Therefore, the officer in the field utilizing this particular kit could then detain the individual. This sample, however, would then have to be submitted to a forensic laboratory, in this case, a forensic drug laboratory, for confirmation. All right, one thing we got to be mindful of when we're utilizing these kits in the field is they do have an expiration date. So we want to make sure we utilize them before the end of that expiration date. We want to check the lot numbers. It'd also be a good idea that you actually run a control, actually having known samples to ensure that these are working correctly. Another factor too is environmental conditions. If these are stored in a patrol car for any length of time where there's extreme heat or cold, they can actually affect the reagents when it comes to their sensitivity. Okay, we may or may not be able to detect some of the things that are present, or you might get some false positives due to the expiration and or the environmental conditions that these reagents were exposed to.
For colorimetric tests in particular, there are limitations. The tests require a very small sample. Overloading may cause errors. These tests are for dry samples and liquid should not be added. Timing is crucial to ensure the most accurate results. If the sample is read too soon or too long after processing, a false negative or false positive could result. Another limitation is color interpretation. Results are read by looking at the kit's color and comparing it to a chart. This comparison can be subjective or influenced by color vision issues. A field testing program will be most successful with good structure, including competency training, quality assurance, regular refresher training, and program coordination between all departments within the system. Many agencies have implemented a Field Investigation Drug Officer Program, or FIDO, to ensure every step is properly applied. An officer's knowledge, training, and experience, coupled with a well-established partnership with the forensic laboratory, are imperative for a successful field testing program to streamline drug cases and ensure proper use of presumptive test results.
Well, welcome back from the colorimetric video. We know that was a longer video, but one of the reasons we had to do that was for the standard public to understand and not misinterpret what a presumptive test was and how important to know that those are not conclusive tests. We started shooting that video and trying to make it as short as we normally do our other videos, but we found out we had a lot more questions, so we had to go back and actually shoot that. That becomes one of the real challenges for you as you go forward in your career. There are things that you may have to do that you haven't thought about, and one of those is being on-screen talent for videos like that and explaining and using science. Don't forget that you can ask any questions by going on to YouTube and typing that in the chat box, or tweeting at NFSTC on Twitter. One of the things I wanted to talk about, I had talked about the Detectichem device itself, and they have come up with a new level of technology, which when we talk about things going into the field, we'll probably be seeing more of. This happens to be what they call mobile detect. This is just the colorimetric detection tool. It still has a QR code. It's got windows where you can look at the color development, but it runs on a phone with an app. So you're actually using the camera on your phone, their software app, to do the same test that you can do on this device. Now, one of the things you should know is the cost for the app in this is much less than this device. So one of the things end users are looking for is more functionality at a lower, more sustainable cost. And one area that we've done work with Dr. Barry Logan, that you guys should know very well, is in the area of oral fluid testing. We're in the process of having a final report done on oral fluid testing for people who have used various types of drugs. And much like a breathalyzer, and it took a long time for breathalyzers to get as sophisticated as they are now, oral fluid testing is moving in the same exact way. And one of the reasons that that is so important is that with the legalization of marijuana, while it's not illegal to have some of these substances in those states, it depends on the individual that's using them and what they're doing. So one of the things that's gone on is looking at new technology for oral fluid testing, very similar to the tools I've shown you here, but they become widely available. Again, as I mentioned before, law enforcement agencies can buy these, and if they don't know which ones to buy, they could be buying ones that are not as effective as other technologies. You have to look at the accuracy and reproducibility, just like you would a laboratory experiment, and what's the legal backing and use. So again, in working and looking at late alpha, early beta technology, we were very fortunate to be able to work with Dr. Logan and his team at the center there to be able to perform the analysis not only on how reproducible it is, does it work on synthetic oral fluids, but also what about environmental conditions? What if they stored these the wrong way? Does it affect the test results? So again, your role as a scientist is probably going to be an end-to-end solution. So you're going to have to look at the technology before it gets fielded. You're going to have to do some type of workflow and quality assurance that goes with it, as well as providing the reach back to the people in the field. The other thing you're going to have to do is training. And while it sounds simple to do training, you need to take the training as far as you possibly can without trying to make it an academic exercise. They need to know the pluses and minuses of the technologies, when things go wrong, how do you fix the quality assurance processes, good laboratory practice or good field testing practices, as well as giving them some backup material, a job aid or a flip book that they can refresh themselves, because if they don't do this testing every day, they do lose those skills. They're what we call perishable skills. You have to be the backup for that phone call at 2 a.m. if you're the one that's on call to answer questions, and you have to review the field test. You may actually have to do additional testing if it does go to court and they want a full test. So again, if we look at what your role is as a forensic scientist, it will be to perform the analysis as well as to be the subject matter expert for people who are potentially doing field testing if it's in your area of expertise. I talked a little bit earlier about rapid DNA technology, and if we look at where the rapid DNA technology is going and how long it's taken, I think you guys might be surprised to know that the first funding from the National Institute of Justice for microfluidic DNA testing was in the late 90s, early 2000s. We're now in 2018, and they just passed the law last year allowing the use of rapid DNA technology. Right now, it's really limited to looking at single source samples at a booking station, but that same single source sample could help laboratories with their backlogs by presenting just enough samples so that we're looking at DNA samples that are the most probative for testing. If it's a bunch of blood drops and it looks like they came from the victim, if we can tell you that they all came from the victim at the scene, then you can actually start looking for the suspect blood or other types of evidence that go along with it. That's really, really important. The other nice thing about the rapid DNA technology is if you look at it, it is really a robust technology for people to use in the field as long as they have the right training and they know what samples to use. Again, these are not multi-systems, meaning that all the processes are done in one system. Whereas if you think about taking things and you do an extraction, amplification, all those types of things in separate devices, these combine them all. Currently two versions out there. You may or may not be aware that Endogenics was purchased by ThermoLife Technology, meaning you have two systems. One is Andy, which is they're very similar platforms, and it's a system that was developed to support both law enforcement and the military. And then the Endogenics, the same thing, law enforcement and the military. However, it was just purchased by ThermoLife Technology. So you do have two systems that are available to you out there. They work well. The data is good. There's been a lot of tests and evaluation of that. The FBI has done testing on it. NIST has done testing, and several state and local labs have done testing. Rapid DNA has risen to the point that there are several working groups on that. ASCLD has working groups on rapid DNA, as well as does the Department of Justice. There are limitations. While you can put a mixed sample in there, it doesn't give you a red light, green light answer like it does on a single source sample. But that doesn't mean that a trained forensic scientist like yourself could not deconflict that type of mixture using standard tools you would use if you got a mixture in a regular forensic case. Really, right now, they're looking at booking stations. If you think about rapid DNA and other biometrics, and the term biometric covers things like fingerprints, facial recognition, as well as irises. So it is really, really important to know that this is just another preliminary tool, because if you were looking at this from the standpoint, just like you would a database sample, you would still rerun it to match if you had a match on the system. This can be used for kinship samples, meaning that you can have a mother, father, child that's trying to immigrate into the United States, and you can look and see if they really should be together. It helps potentially counter human trafficking and other tools like that. It has a great application for deployed laboratories that we were talking about. They provide a setup for being able to look at those laboratories. It can help in natural disasters, just like the tsunami that just hit. They're already burying those people. We could have collected samples to make sure at some point in time, if we had loved ones, we could match and repatriate those victims of the natural disaster. It does work well in remote locations as far as being able to run off good, clean power that you can get from a generator. One of the other areas that we can look at are things that are not currently fieldable, but could be developed into being fieldable. Things like ballistic matching systems. Right now, NIBIN is a really lab-based system. There might be in the future where they take some of these systems to the scene and be able to catalog and search through various cartridge cases found at a scene. So that's some future things. They tried that early on. The technology wasn't there. The concept was. So we keep looking at that and looking for new technologies. One of the areas that I want to talk about is doing some maritime testing. So as I mentioned early on, I'm in the midst of finishing up my PhD in forensic chemistry from the University of Western Sydney. And my area that I'm looking at is the application of forensic deployable laboratories in the maritime environment. And the reason that we're looking at that is sometimes we don't have access to the ground. We have access to the water around a location. Or we might actually be doing support to Coast Guard, Navy, or anybody else that actually was looking at doing what they call a vessel boarding search and seizure. So they actually go pull over a ship and look at it. So if you've seen the movie Captain Phillips, you know that we have things called pirates out there that actually take over ships. Well, sometimes there's ships that are shipping all different types of things that are trafficked. Could be humans, could be weapons, could be drugs, could be explosives, could be just about anything. Could be endangered species parts. So what they want to be able to do is to be able to get on that shipboard, because you can't, it's really hard to stop a ship. It's not like a parking lot. So you got to be able to do what you can. If there is something, they can tow it to a location. If there's not anything that's bad, they let it go. So they want to look at people's cell phones. They want to look at people's fingerprints, who's on the boat. They want to be able to test unknown chemicals and things. So they have the need to be able to put this technology shipboard. One of the things that we found was, while the technology had been vetted for land-based operations, ships provide a whole new host of variables that we didn't think about. Things like pitch, roll, yaw, vibration, weight, power. Those things all have to be handled, and that's where the combination of a deployable facility plus fieldable equipment make a lot of sense. So when we talk about deployable laboratories and deployable facilities, it really changes what you and future forensic scientists will have to do. Unfortunately for you guys, and very fortunately for me when I started out, and if you talk to any of your professors, if they're of a certain age, if I said I was a forensic scientist 30 plus years ago, people said, oh, that's nice. Now, if you say you're a forensic scientist, they're going to want you to solve every case. They want your input on every case. If you sit on an airplane, that's 2.5 hours or longer that you could be trapped talking to someone about every case known to man. So now I just say I'm a consultant, and that way they don't ask me anymore. But it's important to share the knowledge you have and to keep the science and accuracy in the forefront of when you're talking to these people. One of the most important things that I've learned over the last several years is how necessary it is to get really good at communicating with not only your colleagues, but the triers of fact and the general public. It is important, and we're blessed here at the NFSTC. The folks that are helping me put this webinar on are communication experts. And they've taught us a lot, because as scientists, we're really good at getting to the facts, nothing but the facts, and here's black and white. Sometimes that doesn't play very well into our favor. Always before, it was do your research, do your casework. If you're going to write it up, you're going to submit it to the standard forensic journals. It's going to take a pretty fair amount of time. As long as people have access to the journal, they'll be able to read it. If not, they'll have to pay for it. If you haven't been following some of the recent changes, EU funders for grant-funded projects have said you shall publish in open source journals, meaning that you, if you get a grant, have to think about what that means. Because a lot of times these open source journals don't do it for free. They ask you to pay to have an article published. Some people would say it's pay for play, but that's not absolutely true. What they're saying here is if this is paid for, then it's open source to everyone. So you have to look at those journals and what that change might be. There are several resources out there that you may know about, you may not, but I like to bring some up to you just in case you're towards the end of your academic career or just starting even. There's things like Sharing Science. It's a great way of looking at how to communicate your science now. One of the things that we've seen over the last several years, and I don't know how many people are members of the American Chemical Society, but Chemical Engineering News has done a great job in looking at how people receive, read, and understand science. And there's really some great tools and technologies out there which are not your standard format for presenting science and technology, but it may get read by people that you don't think about. One of the most important things that you need to think about too as you go forward, depending on where you're at in your career, it's really important as you're moving up, going from a bench analyst to a supervisor to maybe even being the lab director. You need to work with your agency's public information officer and your media outlets. Because if you're like me and you Google forensic science, there's a lot more bad news stories than there are good news stories every day. And one of the things we don't do really great at, or haven't in the past, we're getting better, is putting out the stories in front of there being a problem. I don't know how many people followed National Forensic Science Week 2 weeks ago, but one of the things we've always done is really push hard for having agencies to participate in that. And that takes folks that are not set in their ways, that are willing to talk about it, willing to put things out there, maybe a little controversial, maybe a little funny. Don't know. But that gets us in front of the general public in a positive way, unlike sometimes how we're portrayed when it comes out as a bad news story. We've been involved in plenty of bad news stories, and if you look at a lot of them and tear them apart as a case, you would figure out that a lot of times there were questions asked and nobody ever got back to anybody. So in the absence of information, some people made up their own stories. So that's something you guys can control in your future as forensic scientists. You really need to control that narrative in your laboratory. It's important to talk to things outside of jargon, and you don't want to put spin on everything where the title is the only thing that's there. There's no meat underneath that. So you got to be really careful and make sure that when you're talking to people, you're giving them the real science, education, as well as the actual information. So forensic science is way more than just laboratory work. I have to tell you that, again, I started by saying if it became a job, I was going to find something else to do. 34 years later, I have the best job in the world. It's a career. I've made lifelong friends globally. I've traveled places I never would have thought I've helped people, and I think that's really, really important. We've got some time for questions and answers, and I really want to say thank you for your time today. Thank you for being a forensic scientist. Please stay in touch with us here at the NFSTC at FIU through social media. And again, we'll be sending some resources and links after today's presentation. Okay, so the question is, where do you think the direction of field forensic science is going? If we look at traditional forensic laboratories and some of the challenges they have, it becomes a capacity problem. Because years ago, all the work had to be done in the laboratory. If you think about what can be done in the field that's equivalent or almost equivalent to what can be done in the laboratory, field forensic analysis is moving towards people getting a ready intelligence answer, hopefully picking the most probative samples and sending those to the lab who can actually either do the more complex cases or actually get an answer that's accredited in an accredited facility back to the investigators in a timely fashion. And that becomes really, really important. If you take digital evidence, for example, and you look at the San Bernardino case where the iPhone was locked and it took months and months and months and months, there could have been information on there about other attacks or other things that may have been forced in doing this. Had they been able to get that data turned back around quickly, then we would have known what the investigators need to do next. So the field of forensic science is one that's moving towards growth. I think you're going to see people who work in crime scene units or do field forensic work looking at more educational and academic opportunities. We see that already. We get a lot of questions about that. If you've been to the NFSTC at FIU website, we have a lot of online tools and classes for folks. We have a lot of tools and information just for the general public. And so those things we see a good response to. So field forensic science, because people can buy this technology, will be able to do that. The question is, what is the process that mobile testing devices have to go through to be accepted? Just like any other technology, there's either standard validation tools and technologies that companies do before they put it out there. Then there'll be operational validation that laboratories or agencies should do with that type of testing technology. Many of these validations, both fundamental and operational, have been done. Agencies should then go to the next step and see how they would be used in their workflow and what their policies and procedures are when they should use this technology and when they should send things to the laboratory. So for example, even though a technology could give an answer, let's say it's a destructive field test, field portable GCMS, and you only have a trace amount. Unless you can keep some of that sample to be tested again, then the process would be don't use it for trace amounts that can be destroyed because we might need to do additional testing. Or we don't need a large amount of it because it's fentanyl and it's a security handling problem. So we could do some testing in the field out where they're wearing proper protective clothing and giving an answer, and then a small amount of that would be transmitted to the laboratory. So you still have to do the standard validation. And that's where a lot of these companies, when they're looking at late alpha, early beta technology, look for people to help them look at that technology, or the federal government may have somebody do that. We'll hang out just a couple more minutes, see if we get any more questions, but again, we're able to answer those and really pleased to be able to help. Those were really good questions, particularly the ones that deal with workflow and validation, because as I mentioned a couple times in the talk, anybody could buy this technology, but if they implement it wrong, then it has a negative impact on its usefulness across the community. So having that ability to be able to make sure you have workflow training and quality assurance and good practices. They're not in the laboratory. We still call them good laboratory practices because that's what we grew up on, but they're really good practices, meaning we're not going to try to test something outside the limits of the technology that they have. You may have to look outside the traditional working at a law enforcement agency. There are several jobs that are potential for someone like yourself, Brian. Have you looked at any vendors or other companies where they're looking for somebody to either do applied testing or do this validation work that we're talking about is a potential. You might find that there are side areas like hazmat teams that need somebody to help them collect evidence, which you would not typically look at because you're a trained scientist and have a bachelor's degree. But I would look at some of the non-traditional places where they use forensic science. So, I mean, it is hard because there's a limited number of jobs. I don't know if you use the ASCLD jobs list, but there's a list on the ASCLD website for jobs. The other thing is you may have to move outside your local area. I don't know if you've looked wide and far, but crime scene jobs are starting to require people to have degrees, so that might be helpful. Well, with that, I appreciate your time. Please follow us here at NFSTC at FIU. Reach out to us, and you'll be able to get some information that you need.